So this is a review of the solution of the AP Classroom Unit 9 Free Response Question A. So part A, we have this nice picture here of these little circles. And the functions are R1 is 2 sine theta and R1 is cosine theta. And so we could figure out that the one with the larger coefficient is going to be the larger circle, so we know this one's R2 and this one's R1. So the first thing to say about it is that a lot of people who attempted this set it up like this. They looked at the area and they were saying, using our formula, area equals 1/2 the integral from alpha to beta of R2 squared minus R1 squared d theta, right? So this is your standard area between two curves. But here's the thing. This would not give you the area S. If you find where this angle is, where the two curves intersect, and you do R2 squared minus R1 squared, well, what starts from R2 and ends at R1 is this segment here, right? So this is R2 minus R1. So a segment that begins at R2 and ends at R1, and you want to think, passing ultimately through the origin. So what you're really finding, if you add up, make an integral of R2 minus R1, is you're finding this area out here, all right? So the thing is, that's not S. So if we want to find the area that they want us to find, that's in here, and it goes from the origin to R1. So we're looking at from the origin to R1 up until we get to this magic angle, which we're going to have to solve for, and then it's from the origin to R2, from the origin to R2. Right? So from R2 to the origin, so we don't even need R2 minus R1, although you can think of this R1 here as being the R2, I know that's confusing, minus the origin, which is 0. So in this equation, from theta equals 0 to the magic angle, let's call this magic angle, I don't know, t, okay, we'll call it t. So from theta equals 0 to theta equals t, the R2 in this formula is R2 from our equation, and the R1 is 0. Then once you get past t, you're going to do another one of these, and the R2 in this formula is R1 of this diagram, and the R1 is 0. So really, you don't need R2 minus R1. You're really looking at area equals 1/2 the integral from alpha to beta of R squared d theta. And you're doing two separate integrals. You have to break up the interval. So we have to say we're going to go from 0 to the magic angle t, and then from the magic angle t to pi over 2 will bring us back here. So we're really looking at this one not being helpful, and we're looking at the area of S being equal to 1/2 the integral from 0 to the magic angle t of the first function. The first function we encounter here is actually R2, which is 2 sine theta. All right, so 2 sine theta squared d theta, and then plus, then the second part is from t to pi over 2, and we're just doing our R1 function, which is cosine theta. So plus the integral from t to pi over 2 of, what's that one? R1 cosine theta, of cosine theta squared d theta. So basically, like, that's the setup, and for people who had trouble with this, if you've got that, you've really got the whole thing. So we can finish it out, but you can really take it from there if you like. We need to find out what this magic angle t is. That means that we need to know where 2 sine theta is equal to cosine theta. So to solve for t, we need to solve 2 sine theta. Oops, that's not a sine. 2 sine theta equals cosine theta. And there are a lot of different ways you could do that, but the simple way is by graphing. So we'll just make a graph of y. Oh, I have to turn it on, obviously, and check my mode because I was doing geometry earlier, so we got to go back to radians. If you're in physics class, always make sure you're in radians when you do your calculus. And we're doing, yeah, we want to know when 2 sine theta equals cosine theta. So we'll go to our y window. We'll put in 2 cosine x. Oh, let's just clear all that and start over. 2 cosine x. And then our other function is going to be sine of x. Make sure I got my functions right. I do. No, I have them totally wrong. It's 2 sine theta and cosine theta. See, this is just like being in my regular class. Let's see, we need to change this to sine. And we need to change this one to cosine. There we go. Now, does that match? Yes, it does. 2 sine theta is cosine theta. Okay. Now, we'll think about our window, too. We want to know when these two things are equal. We know it happens somewhere between 0 and 2 pi, just from the picture. So if we set our window, especially if you have, a slower calculator, let's have the x's go from 0 to 2 pi. So 2 pi. And then for our y min and our y max, well, our functions are 2 sine theta and 2 cosine theta, so they can't be bigger than smaller. They can't be outside the interval -2 to 2. So let's set it -3 to 3, which it already is there. That all looks good, and let's just graph it. Dun, 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 dun. There's the first function, there's the second function. Oh, by the way, the other way you could do this is create a function that is 2 sine theta minus cosine theta and find the x-intercept. I chose to graph the two functions and we'll find the intersection. So we're going to go second calc, intersect. And let's see, is that your first curve? Yes. Is that your second curve? Yes. Why is it important to pick a guess? Because that's the seed value for whatever iterative method they're using. Since you're in BC, we can actually talk about that. They're going to use something similar to Newton's method to solve the equation. So the closer you pick a seed, that's like your x0 for the method. The closer you pick that to the correct value, the more quickly the iterative process will converge on a solution. So here we got x equals 3.602. All right, so what's wrong with this picture is that x is not 3.602 because that is larger than pi. So it must be we want this solution over here. But I thought I set my x's only going to pi over 2. Oh, I put in 2 pi instead of pi over 2. Pi over 2 is what we wanted that to be. So what we can see is that what we wanted was the other solution, which is right there. That's the one we want. So by noticing that the solution I got was outside of the interval 0 to pi over 2, I realized that I had set up the window wrong. And now that we've got that fixed, we can go second calc intersect. So calc the intersection. Is that my first curve? Yes. Second curve? Yes. Give it a nice good seed value, and we should get something that's between 0 and pi over 2. We get 0.4636, which is what a lot of you guys got. So now we know that the t is equal to 0.4636. We're not done calculating, so we shouldn't use a rounded value. So now they want us to find the integral. We can take advantage of the fact that this x is now stored as the x value as a variable in our calculator. So we can go to our integral window and go 0.5 because I'm too lazy to do 1/2. Then we're going to do math 9. We're going to do the integral from 0 to, and I just hit the x button. That's going to use the x that I already calculated just now for t. That way I don't have to write it down. I don't have to round it. It's going to be a nice exact value. I need to do 2 sine of theta squared. And we'll call that dx, even though it's really d theta, it doesn't matter the variable. And then I'm going to go ahead and put in the other part too. So plus math 9. I tend to run all these expressions together. Some of you guys like to separate them out into parts. Arguably, that has certain advantages in terms of editing and being able to see that you're doing it right. So then I have cosine x, closey, squared dx. Now I've written a nice long thing that's going to take it a while to calculate, so I'm going to check it over first and make sure that it matches what I wrote up here. Oh, look how I forgot the 1/2 on the second integral. Thanks for pointing that out to me, Nilla. Yeah, there's supposed to be a 1/2 right there. right? Because both of these integrals are using this formula 1/2. All right, so that means I need to insert that 1/2 right here. That's why I check my stuff over before I hit the button. So insert 0.5, and now that looks good. So I have 1/2 the integral of cosine squared dx plus I have integral of 2 sine squared, 0.5, I have 0 to x here, and I have x to pi over 2 here. I like it. I think it looks good. I'm going to hit enter, and I get the answer 0.240. Now I'm giving my final answer, so I'm going to round to 3 decimal places as we do. 0.240, area equals 0.240. I might ask myself if that makes sense for this picture. So I'm looking at this picture. This is a radius of 1. This circle is radius 1. This is radius 2. This is a very small area. It makes sense, right? If I think of a square, this is a circle of radius 1. So if I think of a square like this, a unit square, does it make sense that this area here would be about 1/4 the area of that square? I will say that's at least plausible.